I'll do is I'll play a little bit of the original version for you. I want to do one more thing with this problem, so I'll come back with part, whatever I am on, the next part, and we'll see what, I'll give you I found a recording of that original version. Now, how did we do? How'd you do, all right? The output force is 60. 60, weight of the bucket is 60. 20 to turn the crank. Okay? The DO is going to be the crank shaft, the smaller. Always think DO, smaller. Okay, DI is larger, okay? Now, two pi r RO output, 2 pi r input. So it's 2 pi times the radius, 2 pi times 0.1, 2 pi times 0.4, 0.628, 2.51. The WO is this times this is 38. This times this is 50. This divided by this is 3. This divided by this is 4. Now, there you have it. Okay? Yes? The 2 pi's cancel out if I want to look at it that way. The only problem with that is you won't get a correct work reading. You won't get a correct work reading. If you divide it through so the r's cancel, then, or they multiply, they divide out, that would be a correct FI reading if I was going to this times this divided by that. But be careful with that, because if you just said 0.1, 0.4, you're not getting a reading of the distance. So the work would be wrong and everything else. Now, the IMA would still be okay because the 2 pi's cancel. DI over DO, 2 pi R, 2 pi R, the 2 pi's cancel. But just be careful with that circumference rule, this canceling, when it comes to actually doing this. The efficiency, this divided by this, or this divided by this, there's round off error there. If I do this, I'll get 0.76. If I do this, it's obviously 0.75. That's obviously the more correct one. That's just a round off error, okay? 0.75. Now, I want you to do an analysis of the kinetic and potential energy. I'm going to erase this, and we'll do an analysis of the energy of conservation. Now, just a side note. You see, if you lift the bucket directly, it's 38 joules. Okay, if you lift it directly. You might end up with back surgery, but if you use the machine, you're doing more work. The best case scenario is you break even. Output equals input. Never happens. The input is always larger, and that's just the way it is. So you can see right here, you're doing 12 extra joules of energy, of work. So, yeah, you won't break your back, but you're going to be tired. You're doing more work. Okay? I want you to see if you can write out an analysis of potential and kinetic energy changes. Just think about it, okay? And when you come back, I'll have that recording, okay? The original. Interesting.